Hello everyone, and welcome to SAM Solutions Tech Talk, your go-to source for tech and business insights. I'm your AI-generated host, Sarah, here to connect listeners with our IT experts. Today, we're delving into SQL Optimization Episode 1, titled Fundamentals from SAM Solutions' recent Meetup. This episode offers an onboarding guide with several essential lessons discussed at the meeting, intended for professionals who may not be database administrators or domain experts. Before we get started, I'd like to announce the upcoming Episode 2, titled Advanced, where we'll dive deeper into more sophisticated aspects of SQL optimization. Stick around. Our guide today is Dzmitry Verasau, a seasoned software engineer, team lead, and Chief .NET Technologist at the Warsaw office of SAM Solutions.
Thank you. It's great to be here. Over my 15-year career at SAM Solutions, I've been deeply involved in desktop, mobile, web, and enterprise application development, working with technologies like .NET Core, C#, ASP.NET, SQL, and others. I have witnessed the evolution of technology and its impact on application development. One key lesson I've learned is that sometimes to reach success, you need to experience failure firsthand. Difficulties have emerged in some of our projects that we could have avoided had we had the knowledge we have today. That's why I'm happy to share my experience and have started a series of meetups called What Developers Should Know About SQL Optimization. It's worth nothing that at SAM Solutions we leverage both time-proven and innovative technologies, implementing best practices and solutions in both our own and our clients' projects. In our commitment to enhancing productivity and knowledge exchange, we actively incorporate AI. For the utmost convenience for our audience, we don't just present our meetup highlights in the blog format. We also use advanced solutions to generate lively podcasts for those of you who are into audio. Yes, the AI assistants will speak on my behalf, conveying my thoughts. And stop worrying, I'm still here, keeping a close eye on it.
Dzmitry, let's dive into the heart of our topic. Why does SQL require optimization? Can you shed some light on the critical role SQL optimization plays in database management and application development?
With great pleasure, Sarah. SQL optimization is paramount for several reasons. SQL, being a powerful tool for interacting with relational databases, can lead to performance bottlenecks and poor user experiences if not optimized. Here are 6 key reasons why you need to optimize: improved performance, resource efficiency, scalability, cost reduction, consistent response times, and finally, data integrity. The primary goal of SQL optimization is to enhance the overall efficiency of your system, and here's why it's crucial. As to improved performance, optimized SQL queries can execute much faster than poorly written ones. It means your applications and systems can respond to requests more quickly, providing a better user experience. Speaking about resource efficiency, I'd like to mention that inefficient SQL queries can consume excessive server resources, including CPU and memory. For the reliable and predictable operation of an SQL server, it is recommended to avoid deploying other applications on the same server. In rare cases, this is acceptable with an additional resource allocation configuration. Next is scalability. As your application grows, the database workload increases. Optimized SQL queries can handle a higher load with the same hardware, delaying the need for costly hardware upgrade. This scalability is crucial for accommodating more users and data without compromising performance. In terms of cost reduction, I'd like to point out that inefficient queries can lead to increased operational costs, especially in cloud-based database services where you pay for resource usage. By optimizing SQL queries, you can reduce the number of computing resources required, leading to cost savings. Now, let's talk about consistent response times. Unoptimized SQL queries can result in erratic response times, making providing a consistent user experience challenging. Optimized queries ensure that response times remain stable even under varying workloads. And finally, let's discuss data integrity. Poorly written SQL queries can introduce data integrity issues by not properly enforcing constraints, performing incorrect updates, or causing data corruption. Optimized ones are more likely to operate on data safely and accurately. In essence, SQL optimization acts as a linchpin for achieving peak performance, cost-effectiveness, and data reliability in the intricate landscape of database management and application development.
So, Dzmitry, we've discussed the why aspect, and now let's delve into when, and under what conditions do you need to optimize. To guide us through this, could you walk us through the different categories of databases based on size and record number?
Definitely. Let's break it down into 3 main categories. For smaller databases, if you have a database with fewer than 1 million records, operations are generally fast, and it's challenging to slow them down. These databases, typically less than 1 gigabyte in size, seldom require specific optimization tweaks. Moving on to medium-sized databases. When your database surpasses 1 million records, basic queries can start to slow down. Updates take some time, and you need to carefully consider your actions. We usually see this kind of database in many of our projects, and it's typically under 100 gigabytes in size. Now, for larger databases, once you're dealing with databases exceeding 100 million records and surpassing 1 terabyte in size, any query can be extremely slow without proper handling. Planning schema changes becomes essential for these databases. Well, you know there are no strict limits in the given classification. Databases in the intermediate range from 100 gigabytes to 1 terabyte can fall into either the medium or big category depending on other factors, such as average load and data structure. Yet the medium-sized databases are where the tips offered in our Meetup would be most relevant and helpful. In the Meetup, we focus on Microsoft SQL, but the principles for optimizing queries are similar across different database management systems. Of course, there are many more challenges and solutions related to SQL performance, and what we discuss here is only the tip of the iceberg, so I didn't address any issues related to SQL Server configuration, which can be crucial if not set up correctly.
Now, we're moving on to the main question of how to optimize. Dzmitry, could you elaborate on the methods and strategies crucial for optimizing SQL performance?
There are several lessons we can draw from our experience. The very first lesson is about setting a minimum amount of memory for SQL Server. Databases contain files that store all data in blocks of 8 kilobytes each, called data pages. Thus, if a server needs to retrieve some data, it will load it from the disk into memory in corresponding small bits. Let's say you have a query requiring you to read 8 gigabytes of data while your RAM size is just 4 gigabytes. In this case, each request will demand accessing data on disk drives, a much slower operation than that in main memory. The SQL server experiencing a lack of RAM may, instead of continuing to process the request, await memory release from side resources, which can take multiple seconds of waiting time. Thus, you must know how much RAM is available on the production server. Sometimes, development teams do not have information about the database environment set up on the client side. Yet, this situation should be alarming. Furthermore, in some projects, the production environment, including a database and web server, is located on a single computer with one operating system, dividing memory resources among themselves. The problem, the SQL server, at least in the case of Microsoft SQL, assumes ownership of virtually the entire RAM available on your machine, trying to reserve it for performance purposes. If a web server also uses memory, a slowdown of the whole system is inevitable. To finalize this lesson, let me make a recommendation. When setting up an SQL server that shares resources with other programs, including a development environment, reserve a minimum amount of guaranteed memory by default. With a few gigabytes of RAM secured, you will be confident that the server has room for catching page-based data into memory and executing queries quickly.
Let's move on to the next lesson. You emphasize the importance of understanding what happens when you query data. What exactly is the SQL server doing to process a query?
Oh, most assuredly. When you throw a question at the SQL server, it goes through some essential steps. First up is parsing. Parsing involves interpreting the user's query and constructing a query tree. This initial step tends to be slow, as the server tries to make sense of the request. Moving on to the next stage, plan building is where the server creates an optimized query plan. If this plan is already available in the cache, the server skips this stage, significantly speeding up the entire process. Once the query plan is ready, we enter the execution stage, where the query execution engine interprets the plan. Following that, data access occurs as the execution engine requests the respective data rows needed for the query. Finally, the process concludes with data transfer to the client, involving the loading of data pages into the buffer pool. Plan building is the step to pay attention to. Here, the server distinguishes between fast and slow operations for selecting the required data. For instance, if you query a single record by ID, it should be relatively quick, whereas a request for a data range would hint at the need to optimize. Using a fast profiling tool such as Express Profiler for Microsoft SQL Server or the Explain or Explain plan for commands in PostgreSQL or Oracle databases, you can quickly check query performance data. In particular, keep an eye on the duration and the number of reads and writes for different queries. The more complex the statement, the higher the number of read-write operations performed. I have managed to develop a rule of thumb for my projects. If logical operations exceed 5 to 10,000, it indicates potential optimization problems with the given query and requires further investigation.
Oh, by the way, there are a number of screenshots that support Dzmitry's explanations. Don't hesitate to visit the blog section on sam-solutions.com to review them. It seems to me that we logically move on to the next lesson. I believe you'll manage to shed light on the importance of updating statistics for query optimization. Can you walk us through why paying attention to statistics plays a crucial role in enhancing query processing speed?
Sure, believe me. It's not as boring as some might guess. As explained above, the server starts responding to a request by building a query tree and deciding what action and in which order to take. At the same time, it is looking into statistics, information about the distribution of column values in tables or indexed views. The statistics help the SQL Server estimate the number of rows in the query result, significantly increasing the query processing speed. The server can update statistics based on certain triggers, but I suggest manually running the updating procedure at 3 key times: before any optimizations, periodically on the live server, and after extensive data updates. Let's say your data contains a date of birth with a range of possible values. For example, a minimum point 100 years ago and a maximum at today's date. That gives the server an approximation of the region size where the result will be present. In a hypothetical example of a query for records of persons born later than today, the server will return a null result immediately without even trying to access the table and execute the query. Once the SQL Server has estimated the number of records, it can allocate a corresponding memory size for that number of rows. And what if something goes wrong while processing the query, and the result is significantly larger than estimated? The server will try to request additional memory or write your data into TempDB, a system database. This example explains why the profiler can display write operations for select statements intended only to fetch data, and it is another indication of a non-optimally constructed query. My recommendation is to pay close attention to such cases.
Is there a lesson 4? If so, I guess we can discuss the importance of choosing indexes wisely. Can you explain what an SQL index is and its role in speeding up data retrieval?
Yeah. An SQL index serves as a performance tool, essentially a lookup table that facilitates quicker data retrieval by using pointers. Several index types exist, and using an unordered heap versus a table with a clustered index is a common dilemma. Each index type has pros and cons. Analyze your unique data requirements to make the right choice. The clustered index, automatically created with a primary key, is well suited for range reads. However, it can present problems with random inserts requiring the rebalancing of the binary tree. The situation is the opposite with the heap. Range operations get slower due to the need to sort the entire table, but inserts tend to be faster. Non-clustered indexes can be helpful for fast access based on filters or for maintaining database consistency. They usually refer to the clustered indexes through row locators pointing to the latter's data rows. If your data contains globally unique identifiers, guides, a widespread practice today for security and other reasons, I would recommend avoiding the standard schema with a clustered index. With random guides, inserting every new record will restructure the B tree, slowing the process and causing performance issues. An alternative is to use sequential guides provided by the SQL Server, mitigating the inserts issue, though it brings the security issue back, as non-random IDs are not as safe. There are a few other index types that are worth knowing. Firstly, unique index. Use it to guarantee database consistency and facilitate plan generation for speeding up query processing. Another type is filtered, indexing a portion of rows in a table. Instead of a full table, is often helpful for reducing the space occupied by the index and improving query performance. Finally, an index with included columns. Add non-key columns referenced by a query for faster data access, as the query optimizer would then locate everything within the non-clustered index without accessing the clustered one. Here's an important note about the latter index needs to cover the query. If it doesn't include just one of the requested columns, you may not realize performance gains.
Sounds like we can move on to your next lesson if it's available. There is an opinion that emphasizes keeping the row size as small as possible for optimal SQL querying. Why is minimizing the row size crucial for improving query performance?
Great question. It's related to my 5th lesson. One of the Meetup's activities was an exercise in creating a table optimized for SQL querying, where all participants could comment on the design of the query and recommend tweaks in fields. Our developers voiced and submitted in the chat a variety of solutions to make the table support higher query performance. Without going into the details of each change, a critical design recommendation is to shorten the row size and avoid including just-in-case extras. If you have a wide table with hundreds of columns, fewer data will fit into each page, and an SQL server will need to perform more operations to process the data. Remember that just 1 byte per data row for a table containing 100 million rows totals 100 megabytes. And of course, you need to consider the additional size of an index, if it exists, which can be larger than the table itself. Also, in Microsoft SQL Server, there is currently a size limit of 900 bytes for a field that can be indexed, an index key, with a clustered index, and 1,700 bytes with a non-clustered one. As for the name fields, there is no single correct approach. Let me draw your attention to some common misconceptions about personal names as summarized in a famous post by Patrick McKenzie. For a deeper dive, please check the recommended readings at the end of our post in the blog section of the SAM Solutions site. In essence, minimizing row size isn't just a design choice, it's a performance optimization strategy that wields substantial impact.
Dzmitry, we've been diving into some great insights. Let's talk about stored procedures. Can you shed light on the advantages of using stored procedures in SQL for query processing? And are there any specific considerations developers should keep in mind to ensure optimal performance?
Stored procedures are like the secret sauce for SQL queries. Diving into this, we're exploring the theme I called Lesson 6, Use Stored Procedures, but remember to recompile. A stored procedure, or a grouped batch of SQL statements saved in the database for further reuse, is another commonly used tool for speeding up query processing. But why are procedures faster than regular SQL queries? when you perform the operations within a stored procedure for the first time, it will cache an execution plan by default. As noted in Lesson 2, SQL Server's parsing and compilation stage is relatively slow, which makes rebuilding the schema at each request ineffective. With the stored procedure, the query processor does not need to construct a new plan again, so the processing time is typically smaller. There is one caveat, though. SQL Server uses parameter sniffing to optimize the execution plan of a query based on the values of the parameters passed to it. Sometimes this feature can backfire and lead to suboptimal plans, especially when the data distribution or statistics are skewed or outdated. If there are significant changes in the tables or data, my advice is to recompile the stored procedure, forcing a new execution plan. However, note that this is a workaround, and you shouldn't just add recompilation to every stored procedure. Ensure that the benefits of this solution are greater than the drawbacks of recompilation in terms of the longer planning phase.
Stored procedures. We hear about them a lot. As we explore these lessons, is there anything else you'd like to share from your experience?
Well, here is my final 7th lesson. Use a test database identical to the production. Regardless of the optimization techniques you are trying to apply, these efforts may become useless if your database differs from the one you will deploy in the production environment. The reason for that is apparent. The query speed depends on how much data you have, its distribution, and other unique characteristics of the given database. Well, what if critical or sensitive data is involved that a project client is not inclined to disclose to the development team? In that case, I strongly recommend anonymizing or replacing the data with random values, while keeping the same total row number and exact row size unchanged.
Dzmitry, as far as I know, you used SQL Server Management Studio during the Meetup to illustrate the improvement of non-optimal queries. Could you share one of the real-life examples you discussed and the suggested improvement?
Certainly. During the Meetup, I used SQL Server Management Studio to show several real-life examples of non-optimal queries and suggestions for improving them. For instance, what I dubbed a left outer join problem, often causing troubles in development projects, could be effectively resolved by splitting the original query into 2 separate ones, resulting in a significant performance increase. While these cases are beyond the scope of the current episode, many Meetup participants involved in the discussions expressed their strong interest in holding a follow-up session to dive deeper into the examples and details of SQL optimization.
And that concludes our interview with Dzmitry Verasau from SAM Solutions. Thank you for tuning in to SAM Solutions Technology Talk. If you have any questions or topics you'd like us to explore in future episodes, don't hesitate to get in touch. Until next time, stay tech-savvy and keep innovating. Stay tuned for more insights and hands-on tips in the next installments of the series.